Hey everybody, welcome to CS202 assignment 6 on big numbers. I'm Jimmy, I'm one of the CS202 instructors. So, big numbers. Pretty much we know in C++ we have these fixed size numeric types, like we have int, we have long, we have unsigned long, and so forth, right? So the idea is that they're all fixed in size. So what if, let's say, you wanted to use a really big number, maybe one that's so large that would not be able to fit in any numerical type in C++? And what motivated me to think about this is many years ago, back when we had our ACM competitions in Southern California, whenever we had some problems where, okay, you need to be able to compute large numbers. If you're using C++, you were disadvantaged over those who use Python, because Python has big numbers implemented, where C++ they use fixed size numbers. So one trick is either just use Python, but right now in CS202 it's not really an option, so we're going to be creating our own custom big number class. So we're going to, of course, overload operators on this big number to compute numbers and have this big number type sort of behave like a regular numerical data type in C++. So let's go ahead and now talk about the actual class material. And of course, we have Homer Simpson here who will be paying attention as well to our video. And let's go ahead and try to simplify this entire class. So when you look at this class, this header file, this class definition, you do seem to be a little bit overwhelmed possibly because, well, there's a lot of members to implement in this class. And I'm going to talk about how you can really simplify this quite a bit, actually, because our operators, they do sort of share some traits with each other. So you can actually reuse operators, and you can, of course, massage the input that goes into the functions and be able to use previously written functions to really help you not have to copy and paste a lot and rewrite a lot of code. So obviously we have, I have my descriptions over here, so you can, of course, can read through all that. And instead of reading through this for you, I mean, this is not really an e-book or a e-PDF, if that makes any sense at all. I'm going to just instead talk about everything in this class. So the first thing I'm going to discuss is the private members of bigNum. And we're going to first have this jar star number. So for big numbers, since we can't store these sizes into a unsigned long or something along those lines, we're going to use a character array. So this jar star number is going to be really a C-style string, and the purpose is so you can't use a string library. That would make this program a little bit simpler. So of course we can't have simple programming assignments in CS202 here. So let's go ahead and make this part a little complicated. So we can think of each sort of element in this array as a place value, and we're going to store characters. So index 0 will be that sort of, how shall we say, that 0th place value, and then index 1's that first place value, and so forth. Now, of course, you can have index 0 be your leftmost digit, actually, and then your index of digits minus 1 can be your rightmost. It's up to you how you want to do that, but each index is going to be a place value, and it's going to store a character. Now, of course, I'll draw this up in a little bit so you can get a better visual on this, but this character array is going to store your digits. Now, int digits is going to tell you how big this array is, how many actual digits you're going to have stored in this number. And then bool sign tells you whether this number is a positive or negative. So if the sign contains false, it'll be a positive number. And if the sign contains true, it'll be a negative number. So this is sort of based on, when you do unsigned and signed data from assembly, if the leftmost digit is a 1, it's a negative. So we're going to treat this as a signed bit. So if it's a 1, it's negative, 0, false. It means positive. So we're going to have these numbers. We're going to store each number like this. So let's go ahead and go through quickly the rundown of this class, the public members next. So we have several constructors, And our first constructor is going to be just our default one, which is going to set our number array to a null, set digits to 0, and I guess our sign to false. So it's already written in the PDF. And then this other construct, which I'll talk about in a little bit, is we're gonna pass in some string literal, and we're going to store this into that number array. And then we're going to have our this other constructor takes in some numbers, integer, some numerical type, and we have to convert that into a sort of a character array. And of course, I'll go over some details of that as well. Then we have our standard copy constructor. Nothing too surprising there, just a deep copy of our objects. That's not going to be anything too fancy. Our assignment operator, again, nothing too fancy there. Our deep copy assignment operator, which will be used quite a bit in our program. Then we have our destructor, which simply deallocates our number array. So pretty simple. Now we're going to have our sort of our binary arithmetic operators. So we're going to have our plus operator. So if we're adding a big number with another big number, we're going to return a big number object that contains the sum of big number plus big number. Then this other operator plus function right here is going to be where if we have a big number plus some numerical type. So if you have a big number plus 5 or something, so an actual numerical literal will be used. Then we have to, of course, handle a case, what if you do add a big number with a numerical type? So we'll go over that in more detail, but that's what's going on here. Then a minus operator, same idea, except we're going to be doing a subtraction. So this first one is we have a big number minus big number will be run right there. This one's we have a big number minus some numerical type. Then we have our comparison operators, so our less than, greater than. So same idea. We have a big number, less than big number, returns true if the left-hand side big number is less, and then returns false otherwise. There's other less than operators when we have a big number less than, and actually like an integer, some type of a numerical type, and returns true, of course, if our big num is less, and false otherwise. Then greater than, same logic, except the logic is in reverse or mirrored, if you will. So nothing shocking there. An equals equals operator, we're comparing a big num with big num. If they're the same, return true, else false. And this equals equals if you have a case where we have sort of a big num being compared to a numerical type. And again, return true if they're the same and false if they're different. Then, of course, we have our friend functions. Now, this is going to be needed if, let's say, you want to have maybe, so as for first one, we're going to overload this plus operator where we have a numerical type, then plus operator, and then big num in that order. Then we have to handle that case. And then we have our other big num, or other friend function, sorry, where we have a numerical type, then minus, and then big num in that order. So you can see here that, in fact, you actually can, so for this function right here, you actually can reuse this plus operator, or I'm sorry, actually, you can use this plus operator, this one, in this function scope, and you can also reuse operators as you want, but of course you can see right there how having this implemented function is going to help you right there. And this is minus operators for a case if we have an int and then minus and then big num. It returns a difference. Now, these comparison operators, same idea. This friend functions are used if we have a case where our left-hand side operator, or operand, sorry, is a numerical type, then the operator, and then big num. In that order, we want to be able to handle those cases. Then, of course, we have our output sort of operator, where you want to be able to see out our big num as if it were a regular numerical type. So that was the quick rundown of our class. So I'm going to now talk about, in more detail, how to implement our constructors and how to do long addition, long subtraction. So, that's a very simple concept, right? I mean, long addition was a second grade sort of, you learn at second grade, right? So it's pretty simple, except being able to have a computer do this will be a bit more complicated. So we'll do that. And of course, I'll give you some idea of how to do the comparison ones as well. Let's go ahead and go to the board and sort of draw this up and visualize how this is going to be implemented. Okay, so let's look at this constructor right here. So you may have a case where you actually create an object like this, and this is going to be your literal. That's that literal parameter you have in your constructor. So a string literal will be passed in. So you have to figure out, well, how many digits this actually contains. So remember in C, for C-style strings, of course, the last character is always null. So everything's null terminated. It's very simple to determine this. So in fact, I mean, I can give you a little bit of code right here. You can have an int count equals 0. And while this literal index count is not equal to that null character, just do count plus plus. So every string in C is null terminated. So of course, once you hit that null character, you're done. And in this count is going to tell you how many digits is stored in that literal. So using that, you can easily set, of course, you have the digits field for the object. You can set it equal to this count. Of course, you can allocate the correct size array to number, and then just you have to traverse this literal string array again to just one by one copy each character from this into that number array. And of course, the sign in this case will be set to false. So this is going to work for every case, except what if, let's say, for example, I would have had a negative value instead. So let's say if I would have maybe created a bigNum object like this in main. So I'll say b underscore, I'll call it. Let's say we use negative 1, 2, 3, 4, 5. So we have this. Then again, we count 6, but we first have to check. If that first character in our string is a dash or negative, that means we have to set this object, b underscore, its sign will have to be true. And then this count, in this case, the count will give us 1, 2, 3, 4, 5, 6. It's actually going to be 5 digits again, not 6, because the first character is just going to be that sign, and then really you want actually count to be 1, 2, 3, 4, 5. So then you have to, of course, update the count slightly. So you have to, of course, from index 1, you have to copy all these into number like that. So, of course, that count amount in this code that I provided right here for you is going to count that dash as a digit. So, of course, you have to first verify if that first character is a digit. And if it is, then just, copy it very easy. If not, you, of course, copy it from index 1 into that number array. So you have to, of course, in this situation right here, you would have for this b underscore, its sign would be true, digits would be 5, and then this number array, you want to store the following. So it's going to be 0, 2, 3, and 4. You want to store the following characters. So this number array, so these numbers here in blue are the indices, and these are going to be the actual values. So of course, I actually have it where index 0 is my leftmost digit, but you can have it you can reverse it if you want. So it doesn't really matter how you do this actually, but that's how we can visualize this. So that's going to be our basic sort of constructors right there. Now, what about for the case where, let's say if I'm going to actually initialize an object like this. So bigNum, I'll say b2. And I use, let's say, a number like 345. So in this case, this is going to be your literal, but this literal is going to be a long in a numerical type. So the trick to doing this is, first of all, how do you verify how many digits this number actually contains? So I wrote this into the PDF. Is you can actually include CMath into your bigNum.cpp file. So what I would do is I would just say, of course, log10 function of this literal, and of course you have to static cast this. to an int plus 1, that's going to tell you exactly how many digits is going to be contained in a number 345. So if a literal contains 345, this is going to actually spit out the value 3. Of course, you can test out as much as you want, but this is the actual way to verify that. So this is kind of one of the nice, logarithms can be nice. So you might have learned about this maybe in grade school. You thought logarithms were a very weird function, and they are kind of weird, but this is one nice use of log functions. So given this amount, you can easily verify, you can compute the amount of digits you're going to need. So you can allocate this number array for B2, and this number array will be, the size will be this. You want to set that into the digits field for B2 as well. Then of course you just copy each character over. However, getting each digit is not going to be as simple as pulling it from this string literal, but actually it's a very simple technique. So you can actually do is if you take 345 and you mod it by 10, that's going to give you the value 5. The rightmost digit you want to store into B2's number field. Then of course, if you take 345 and then divide it by 10, divided by 10, that's going to give you a value 34. So you can reassign that parameter with this value, 34. So of course you can just, I think it's called literal in that constructor. So you can do literal equals literal divided by 10. And that's going to reassign literal without that last digit. Then of course, for this new updated literal, you can mod it by 10 again, and it will then extract 4. And then you take that value 4, you have to convert it into a character. So of course, what you can do, a very simple trick, is if you just take, let's say for example, 345 modded by 10, if I take this digit 5 and I add it by the character 0, it's going to give me the character 5. So all you'd have to do is take the digit, so 345 modded by 10 gives you 5, plus character 0 gives you character 5. And you store the character 5 into the rightmost position of B2's number. And then of course you apply this operation to remove that rightmost character. And then using this new updated literal, which is going to be 34 now, 34 modded by 10 gives you 4. 4 plus character 0 gives you character 4. Then you store that into the next position in your number array until eventually this literal will become 0. Because sooner or later, what will happen is you'll have only one digit left, and then divided by 10 gives you 0, and then you're done. So that's how you do that, essentially. So of course you have to check for negatives as well. So of course, before you even do this log 10 literal, you first want to verify if this value is negative. If it is negative, of course, you want to maybe apply an absolute value on that on literal. And of course, you want to set the sign appropriately for B2. So again, of course, you'd have a loop to do this until eventually hit 0. So hopefully this example kind of gives you the idea of how you would write the loop for this. So that's going to be essentially how we do our constructors. And of course, the copy constructor, I'm not going to discuss that, or the assignment operator. Those should be relatively similar to examples you've done in class. So I'll let you kind of work on that. So let's go ahead and now talk about the plus operator next. Okay, so let's go ahead and go back to grade school for a little bit and go into long addition. I hope that didn't sound too condescending, because even though this is a very basic concept, I can imagine this being really, well, this will be fun, I think, or not going to be fun. I don't know. Whenever a CS instructor says something will be fun, it's fun in a sense, but anyway, let's go ahead and just talk about this. So we're going to be adding, so this could be some actual example you could sort of come across in your mains. Now, in the mains I'm providing for you, it's going to be just really big numbers. So you can't, if you're tempted to convert into you're trying to convert it into an int or an unsigned, long, and so forth, it will sort of not work correctly. But we can sort of show you how to do this on a small example. And of course, this can scale up to a larger example. So we have B1 and B2 set, and we're going to add them together right here. And then we're going to return the sum object, and result will catch that sum object. Okay, so here is the contents of B1 and the contents of B2. Now, in our function body, we have this parameter called RHS. So since B2 is your right-hand side object, this is going to be your RHS. I'll put this here. This will be your RHS object. And then B1 is going to be your this object. So this will be your left-hand side object. And then RHS will be this object, B2. So as we can quantify these two. So let's go ahead and sort of think about this. Let's go ahead and just now, I'm going to maybe just put this up here. So we're going to have 989 Studios. So if you remember, if you ever played the old PS1, then you might have heard that term being used, 989 Studios. So of course, then we have 3 and 3. So we're going to add these two numbers together, or we're going to sum these up. So of course, you want to create possibly a temporary object in this function body. Maybe you can call it bigNum sum. So the first question is, for this sum object, how many digits will this sum object contain? Well, we have this arrow digits, which is going to be the amount of digits for this object. And we have, of course, RHS digits, which is going to be this. So we have 3 and we have 2. So I would assume, so for right now, the safe thing to do is you can just say, well, the amount of digits, the sum will be 3, at least for right now. It could exceed 3, but for now we'll say it's going to be size 3 because we take the max of these two numbers. Now, the issue here is that since these numbers are not the same number of digits, we're going to have to add leading zeros into RHS.digits. Now, of course, there are other ways you can do this. I actually was able to find a workaround and not have to do this. But one technique is you're going to have to maybe create another object or another pointer of some sort. You're going to have to add a leading zero or leading zeros to this number. So I'm going to go ahead and move this over for a second right here. Oops, I think I didn't copy all this correctly. It didn't move correctly, actually. So it's okay, this is acting up on me right now, OneNote. So you're going to want to add this digit in front. So you have to add zeros in front and move it over, but it's going to involve you having to create a new array, allocate the array of size, well, whichever one is the larger, and you have to add leading zeros in. That's going to be a little bit complicated, but of course, there are ways to get around from doing that. I'm just not going to explain that to you, but there are ways of getting around it, but the very simple ways do this. So now what's going to happen is, in this case, I'm going to just put the sum object right below for right now. So we're going to create this sum object right below. It's digits. Actually, I'm going to put a sign first. A sign is going to obviously, it's going to be false. And it's because we're adding two numbers that are both positive, so there's no way the sum can be not positive. Then the digits, for right now, we're going to have it just be 3. And then the sum, its number field, well, we're going to have it to be size 3. So I'll put a 3 element box right here, like that. And I'll use a different color to highlight. It's going to be the indices. And for now, I guess, doesn't matter what we put in, but I'll just sort of set it all to be just 0 for right now, just to be safe, like this. So now we have to write a loop that's going to start from the rightmost position of number 1 of this arrow number, and then, of course, RHS dot number. So we're going to have to do the following. We're going to have to go ahead and just do this arrow number at index I, and then we have RHS dot number index I, where I will be initialized to the rightmost position. So we'll just say for right now that I will be looking at this. So of course we have to convert them into integers, so we have to subtract them by the character 0 for each. And of course we can store these into two variables. So then D1 will contain the actual integer 9, and D2 will contain the actual integer 3. Then we have to add these up, and we get the value of 12. If we add up D1, so we do D1 plus D2, we're going to get the value 12. So let's look back into our second grade long addition. What do we do now? Well, we have to end up getting the following. We have to store the digit 2, because we have 12, so you have to store 2 into the same position as our sum. So of course we have to get the value. You have to somehow, how do we get 2 from this number? I mean, maybe mod division of some sort, maybe mod by 10. That could be a good idea. We get the digit 2 plus character 0 gives us character 2, and we store character 2 right there. Now, here's number 12. How do we get its carryover? Because we have to add, you have to carry the 1 over to the left side, correct? Remember from second grade math, or that must have been a long time ago, but you know, you had to, I guess you still apply this long addition to this day, I'm guessing, in some capacity, so you didn't forget. But of course, the problem is there's certain things that are so obvious to you. Remember, a computer doesn't really know this. You have to be very careful and tell it exactly what to do. It's almost like trying to teach a second, or let's say a 8th or 7-year-old how to do long addition. So, well, kind of. Anyway, so how do we get the carryover of 1 out of 12? I mean, maybe if you divide by 10. I mean, what's 12 divided by 10? So 12 integer divided by 10 integer gives you 1. Oh, so that's your carryover. And you have to apply the carryover right here. So in reality, now what will happen is I is going to go to the next position like this. And the same idea, we have to get our D1 and D2. So we take 8, character 8 minus character 0 gives us integer 8, plus we take this RHS.number at this index I, which is going to be character 3 minus character 0, give you actual value 3. So then 8 plus 3 will give you, in this case, 11, plus the carryover of 1. So you're going to get 12 again, actually. That's going to be the result of D1 plus D2 plus some carryover of some sort. And carryover in the last step was computed to be 1. Now, the very first addition, when we actually added 9 plus 3, we can actually have a carryover, but the carryover will be 0 initially, correct? So we actually could do D1. So in the last step, we did 9 plus 3 plus 0. That'll give us 12. But here we're going to do 8 plus 3 plus 1, which gives us 12. And again, we can easily extract 2 from 12 and convert it into a character and then store it into the same position as, you know, index 1 of this array. And then, of course, we compute our carryover again to be 1. So we have to assign a carryover to be 1. And we're going to add this to our next result. So now, of course, I will be moved over to this position right here. And then we're going to take the character 9, minus it by character 0 to give us the value 9, plus the character 0 minus character 0, so it's going to be 0. So 9 plus 0 is 0. Plus the carryover will give us the value of 10. So of course, with 10, that right digit will be 0. We're going to overwrite this character from 0 with 0. And then we have our carryover is going to be currently 1. And now we're done, because our loop now will I will go out of bounds of the array, and here's our result. But in this case, we have a carryover bit of 1 that's sort of left over after this. Well, we can imagine this is going to be some kind of a counter-controlled loop. We actually have a carryover left over. So we have to add that carryover to the front. So we're going to have to actually allocate another array to this number of sort of digits plus 1. We're going to have to update digits to actually be from 3 to 4. And we're going to copy these characters in. Wait, is this actually... Yes, that's correct. Okay. So then we have, okay, so there we go. And then of course we're gonna add this character 1 in front. And of course, this is gonna be deallocated. So we're left with this result. So of course, our sum will initially be just size 3. We have to, of course, resize it by 1 if, let's say, there is a carryover at the very end. Now, of course, if at the end, after we finish this loop, if our carryover was 0, then there was no need to do this. So that's going to be our result. So again, if we could use strings, this would be so much simpler. You can do a string concatenation, and then you'd be done. But of course, we're not going to be doing that. So of course, you have to handle a case. Well, what if we're actually going to be, what if, let's say, what if, let's say, B2 was actually negative 33, let's say instead. Now, I haven't gone over subtraction yet, which I will, momentarily, but if I say 989 plus negative 33, that's the same. I mean, think about logically, if I say 989 plus negative 33, is that the same thing as just saying 989 minus 33? I mean, I think it is. So you, of course, can declare objects in this function. You actually can use the subtraction operator over here, actually. So you don't have to actually create a separate case for this. Just go ahead and just sort of outsource this to the subtraction operator. Let it take care of it. So, of course, this RHS object, you can deep copy it into a temporary object. So, I mean, let me give you some advice. You could just say something like bigNum. Oops, if I can spell. bigNum. I'll call this maybe just op for operand. I pass an RHS. I just deep copy it. I'll just set op.sign equal to true. And I could just say return star this minus op. I could even do that. And of course, so if RHS, if I know for sure it's a negative number, I can just create a temporary copy of it, op, update its sign to be, oops, I meant to say false here, my mistake, I'm sorry about that, make it false. And we're going to subtract by a positive, which is the same exact logical step. And of course, we just call the subtraction operator on this object. So you can use this in you can use this sort of logic in a lot of places in your code to really condense your code quite a bit. So anyway, that's going to be your addition operator. Let's now talk about the subtraction operator. Okay, so let's go ahead and now talk about the subtraction operator. And let's go back and think about how to do long subtraction. So suppose we have these objects B1 and B2 set accordingly. We can look at these objects B1 and B2, and B1 has 4 digits, B2 has 3 digits, and these are the actual digits are stored in here. So of course you have 7, 6, 3, 8 are the actual values. And again, we subtract B1 minus B2. We're calling B1's operator minus function. So star this refers to B1 inside that function body scope, and then RHS refers to B2. So of course you can use this arrow number and RHS dot number as ways to be able to distinguish which number are you actually working with. So we're going to have to subtract this, and of course we can create a temporary difference object inside of this function scope. And the amount of digits we're going to have to allocate, well, since we have two objects, B1 has 4 digits and B2 has 3 digits, we can say difference for right now is going to be at most 4 digits, the difference object. So we can allocate a difference object, and we're going to set its digits to 4. And then we're going to allocate a size 4 array to that difference object that we can just define locally in this function scope. So in order to subtract, we again have to line these numbers up, and we notice that once again, since B2 is a smaller number, we have to add a leading 0 to it. Now, of course, there are ways to get around from doing that, but of course, this method will not fail you, so you could have to resize that, or you don't want to resize RHS. You want to maybe, if you're going to resize this number, possibly just create a deep copy of RHS into a temporary object, and of course resize that object. So you don't want to modify the start of this object or the RHS object. So just, if you have to modify, just create deep copies using a copy constructor. That's why we have that, so we can use that as needed. So again, we have to do is we have to, of course, subtract each character one by one. So actually, this example is not great. So you know what? I'm going to actually modify this to be character 1 over there instead, just so I can so we can see what happens. So I'm going to, of course, update this to 1 right there as well, and also update that to 1 over here, so we can kind of see a good example of what would happen. Okay, so again, we're going to have a loop where we're going to have this I will point to this position. So again, we can use the following. We can say this arrow number index I, and of course subtracted by character 0. And of course we have RHS dot number index I minus it by character 0. And it'll give us, we'll have, again, we can have D1 and D2. They'll both be integer type. So actually I'll use that looking symbol, so don't get it confused with the arrow operator. So of course, to subtract D1 from D2 to give us the value we subtract D1 with D2. I get confused with that whole subtract from, I get confused with that language sometimes. So D1 minus D2, there we go. So we get that the value of 4. We add it by character 0 to store the character 4 into that difference object at that same position. Then of course, the next step is we're going to move the iterator or increment that iterator, the index I over to the left. And now we're going to add these two up. Now we see over here that, oh, well, 1 minus 3 is a negative value. So remember, how does this work actually in math? Well, we have to, of course, borrow. So we're going to subtract 1 from this character to give us the character 5. And we're going to add 10 to this sum. So we take the character 1 minus it by character 0 to give us the digit 1 minus, we'll take that character 3 minus 0 to give us the digit 3. So 1 minus 3 plus 10. That's going to give us the value of 8, if I'm not mistaken. I think so, because 11 minus 3 is 8. So 8 plus character 0, character 8 goes right there. So I'm hoping I did this correctly. So I guess 1 minus 3 is going to be negative 2 plus 10 is 8. Okay, great. So I didn't make any mistakes with my long addition. And then, of course, we move our index over to the left once more. Then we have, of course, character 5 minus character 2. So 5 minus character 0 is digit 5. And then minus the digit 2 will be 3. So character 3 goes right here. And then, of course, we move this incrementer or this I counter over to the left again. Then, of course, 7 minus 0. We do our conversions. We get character 7. And then we're done. So this is going to be the actual number array assigned to that difference object. So this is a generic case, but there's a few scenarios you have to worry about. For one, we don't want to have leading zeros. Now in this subtraction, we didn't get leading zeros, but what if, let's say we were to subtract, suppose something like this. 113 minus 111. Then a result could be this. And we don't want to store, we don't want to return leading zeros. We have to actually remove leading zeros from our difference object's number field. So you have to shrink that array if you have leading zeros, because you don't want to use leading zeros. And of course, what if we have a case where what if let's say B1 is actually less than B2? We have to also handle that case. So the result will be, the difference will be a negative value. You have to, of course, be careful with that. So You have to handle it accordingly. But here's one trick. So suppose if I were to subtract 10 minus 20. That's negative 10 clearly, right? But what if we do this? If I say 10 minus 20, couldn't I just do 20 minus 10 to get the value 10 and then just assign that sign field, or I guess not sign feld, but the sign field of that difference, just set it to be negative. So set that sign to be negative at the end. Couldn't you do that? I mean, really, it's going to be the same scalar, but a different sign in front. So of course, you could modify the input a little bit. You can sort of swap some stuff around to, get this result. But of course, you don't want to reassign this or RHS. You can create local objects inside of the operator function. Of course, you can just, modify them a little bit to create, you can use that subtraction to avoid having leading zeros in this case. Now, of course, you still could get leading zeros regardless, but this is a nice nifty trick. Also, what if B2, what if I had B2 was negative 234? Well, remember how that works. I mean, if you say, 7618 minus negative 234, well, that's the same thing as just adding. So you actually can sort of use the addition operator actually in this function body to not have to copy and paste code, but just use your existing plus operator to help you out in this case. So those are some scenarios right there as well. So make sure you sort of eliminate leading zeros and so forth. So anyway, that was the subtraction operator. Let's go ahead now to summarize the rest, but the other operators are going to be not really too complicated. These are the two more complex ones. Okay, so I'm going back to the original PDF because there's not much to really draw up with all of these. So you don't want to use any kind of string library functions to do any of your comparisons. So let's say for operator less, you're comparing if one bigNum object less than another bigNum object. And there are a few very simple ways to handle it. For example, you can check the this object and RHS objects signs. So based on their sign, whether it's true or false, positive or negative, or sorry, true would be negative, false is positive. You can based on that, can verify which number is bigger. So let's say that this object, its sign is positive, and RHS's sign is, if the this object's sign is true, implying it's a negative number, and RHS's sign is false, which is positive, then clearly the this object, the left-hand side object, is definitely smaller. If they're both the same sign, then you check their digits amount. If they're different amount of digits, so since you're supposed to not maintain leading zeros, you can tell based on a digit counter, you can tell which number is bigger. If they're the same sign and then they have the same number of digits, then you have to then have a loop and then one by one compare each character, which character is bigger or smaller. You can just use ASCII characters because of course the ASCII 6 is going to be less than character 7, and of course the ASCII value 5 is less than character 6. Character 6 is larger than character 5, so you can use ASCII character comparisons because you don't have to convert those because they're the same values. Character 0 that's the character 5, the whole deal. So really, for the most part, these are very simple, and you actually can reuse these. So for example, obviously these two operators, well, this one you have a case you're passing in a long, so you can easily just pass this value into a constructor. So you actually can, in this function body, you can create a temporary object, pass this RHS as a constructor into the constructor, and then you have two big number objects. You can of course call this function in that function body, assuming you convert this into a bigNum object using the constructor. So pretty simple. Also, the larger operator is similar to less than. So for larger, for it to be larger, that means it can't be equal and it can't be less. So let's say you want to compare if B1 is larger than B2. So if B1 is not equal to B2 and B1 is not less than B2, well, then you know B1 has to be larger, right? I mean, think about it. So you don't have to copy and paste code. You can just reuse the less than operator in the greater than operator. So there we are. Equals equals, you can't use string comparison. You can't do a string comparison function, but again, you can check if they have different signs. Obviously, they can't be the same. Different digit amounts, they can't be the same. If they're the same sign, same digit, then you have to compare character by character using a loop. That's how you can tell. Then, of course, these friend functions, well, as you can see, you can reuse existing functions. So, for example, this bigNum plus operator with the left-hand side being integer, or long, sorry, you actually can call the plus operator when the left-hand side, so you actually can call, this operator, if I can find it, there we are. You actually can call this operator in that friend function because, addition, I think is, what's the term? I think it's cumulative or associative. Well, it's the one where 4 plus 5 or 5 plus 4 is the same thing. So you can just use that function right there. And same thing for the subtraction ones and so forth. And for the these friend Boolean operators, same thing. You can reuse the member function Boolean operator because it's the same kind of concept. So there we are. And then for the OStream function, that one is simple. So you first check this object B, its sign. If it's true, you output a dash. If it's false, don't output anything. And then traverse each digit of this B object one by one and output each character one by one until you've traversed all the digits of B. So you use the out variable as your cout, because remember, this out could be cout or it could be a file stream. Now it's not going to be, but what if somebody were to use a file stream to output a big number? Well, then this is going to work for either one. So that's basically going to just be the class right there. Let's go ahead and now just talk about, I guess, the specifications I'll mention next. And then I'm going to go ahead and sort of show you some of the content I gave you. So I gave you guys the actual main files, but I'll go over those as well. So just to remind you, just of course, include a block header comment in your bigNum.cap file. Of course, always document all your code. That's always going to be the same. Do not use any library functions. Do not convert your numbers, your strings into numerical types. And you only have to submit just bigNum. So all the main files, the make file, all that's going to be already on CodeGrid. Even the header file will be there as well. You have to just only submit bigNum.cpp, but on Canvas, I will provide you all the files in a zip file as well that you can use. So for testing purposes, you actually can create additional mains as well. So I'll talk about how you can do that as well, just to test it out. So I would suggest before you submit to CodeGrid, and of course, before you check the output, you can create your own custom output. And it's very simple to test. You can just maybe create some small bigNum objects of maybe like 2 or 3 digits. And it's very simple to verify the result to make sure it's working on small size numbers. And of course, it works on small size numbers. Your program obviously will scale up to larger numbers, right? So anyway, I have the example output over here. And I also will have the link to this video, which I guess you're watching the video right now. So I'll link it also on Canvas, but which you're already going to know that anyway, because you're watching the video right now, which means you probably already found the link. Otherwise, you wouldn't be here. That's like, I guess that was like, I guess this is my version of breaking the fourth wall right there. I guess if that's the right terminology to use. So anyway, I'm going to go ahead and now just sort of go over just how you can write some test code that you can use to verify your functions before you submit your code to CodeGrid. Let's go ahead and discuss that next.